Hello everyone, thermal properties of matter 2. In this video, I will be discussing the topics specific heat capacity, calorimetry, and changes in state of matter. So first we shall see specific heat capacity. The change in temperature of a substance when a given quantity of heat is absorbed or rejected by it is characterized by a quantity called the heat capacity of that substance. Heat capacity is given by S is equal to delta Q by delta T, where delta Q is the change in heat energy and delta T is the change in temperature. Specific heat capacity is defined as the amount of heat absorbed or rejected to change the temperature of unit mass of the substance by 1 unit. And specific heat capacity is given by heat capacity divided by m, where m is the mass of the substance. The SI unit of specific heat capacity is joule per kg per Kelvin. Now molar specific heat capacity. If the amount of substance is specified in terms of moles instead of m in kg, we can define heat capacity per mole of the substance by C is equal to S by mu. The SI unit of molar specific heat capacity is joule per mole per Kelvin. But in the case of gases, certain additional conditions are required to define molar specific heat capacity. If the gas is held under constant pressure during the heat transfer, then it is called the molar specific heat capacity at constant pressure and is denoted by Cp. Similarly, if the gas is held under constant volume during the heat transfer, then it is called the molar specific heat capacity at constant volume and is denoted by Cv. Now we shall see calorimetry. Calorimetry means measurement of heat. A device in which heat measurement can be made is called a calorimeter. It consists of a metallic vessel and stirrer of the same material like copper or aluminium. The vessel is kept inside a wooden jacket which contains heat insulating materials like glass, wool, etc. The outer jacket acts as a heat shield and reduces the heat loss from the inner vessel. There is an opening in the outer jacket through which a mercury thermometer can be inserted into the calorimeter. The setting of a calorimeter is as shown in the figure. Now change of state. Matter normally exists in three states. We all know that matter has got three states, which are solid, liquid and gas. A transition from one of these states to another is called a change of state. We know that if we keep an ice cube at room temperature, it will start melting after some time. This is as a result of the heat transfer between the ice cube and the surroundings. And the state of the water changes from solid to liquid. These changes can occur when the exchange of heat takes place between the substance and its surroundings. Now the change of state from solid to liquid is called melting, and from liquid to solid is called fusion. Fusion happens when water kept in a refrigerator turns into ice. Now we can consider an experiment in which 2 to 3 ice cubes are put in a vessel and the vessel is heated. And the graph is drawn as shown in the figure, in which the temperature change is plotted against time. It is observed that the temperature remains constant until the entire amount of the solid substance melts. That is, both the solid and liquid states of the substance coexist in thermal equilibrium during the change of states from solid to liquid. The temperature at which the solid and the liquid states of the substance in thermal equilibrium with each other is called the melting point. It is characteristic of the substance. It also depends on the pressure. The melting point of a substance at standard atmospheric pressure is called its normal melting point. Now, regulation. Regulation can be defined as a phenomenon in which the freezing point of water is lowered by the application of pressure. Some of the consequences of regulation that we can see are: skating is possible on snow due to the formation of water below the skates. Water is formed due to the increase of pressure and it acts as a lubricant. Then, for the second consequence, we shall consider an ice cube and a copper wire is kept over the ice cube as shown with both two weights at its either end. What happens is the wire passes through the ice slab without breaking the ice slab. This happens due to the fact that just below the wire ice melts at lower temperature due to increase in pressure. The pressure due to the weights. When the wire has passed, water above the wire freezes again. Thus the wire passes through the slab and the slab does not split. Now the change of state from liquid to vapor is called vaporization. This can be observed when water is boiled and we can see that water turns into steam. It is observed that the temperature remains constant until the entire amount of the liquid is converted into vapor. That is, both the liquid and vapor states of the substance coexist in thermal equilibrium during the change of state from liquid to vapor. The temperature at which the liquid and the vapor states of the substance coexist is called its boiling point. Boiling point increase with increase in pressure. So the change from solid state to vapor state without passing through the liquid state is called sublimation, and the substance is said to be sublime. It is seen in dry ice as well as iodine. During the sublimation process, both the solid and vapor states of a substance coexist in thermal equilibrium. That is, the substances which sublimes turns directly into vapor without passing through the liquid state. Now we shall see latent heat. The amount of heat per unit mass transferred during change of state of the substance is called the latent heat of the substance for the process. As we have already seen, during the change of state, the temperature remains constant. The heat required during a change of state depends upon the heat of transformation and the mass of the substance undergoing a change of state. If the mass m of a substance undergoes a change from one state to other, then the quantity of heat required is given by Q is equal to m into L, where L is the latent heat, or L is given by quantity of heat divided by the mass of the substance. The SI unit of latent heat is joules per kilogram, and its value is usually quoted at standard atmospheric pressure. The latent heat for a solid liquid state change is called the latent heat of fusion, and that for a liquid gas state change is called the latent heat of vaporization. These are often referred to as the heat of fusion and the heat of vaporization. So this is the end of this video. In this video, I have discussed specific heat capacity, calorimetry, and change of state. If you have got any doubt in any of the topics discussed in this video, please do comment in the section below this video. Thank you.